Hi, I'm Om, and this is my second year in First Tech Challenge, and my first season with Maximum Entropy. I came onto this team as both a lead programmer and a backup driver, which ended up being a really valuable combination. Sitting right next to our main drivers during matches, I got to see firsthand what stressed them out, what slowed them down, and where things broke, and that gave me a clear picture of what our team actually needed, and it shaped everything I built this season around one idea: make the code work for the driver, not the other way around. Before any programming started, I designed the robot in CAD and I modeled the entire thing virtually so we could test how mechanisms fit together and catch any issues before we even assemble a single piece. That saved us a lot of time during the build phase, and I also designed a version 2 of the robot with several improvements, but we ran out of time to build it before competitions. Still, that process taught me a lot about design iteration and thinking ahead. On the software side, one of the first problems I noticed was that our drivers wanted full speed to cross the field quickly, but then couldn't make precise movements when it came time to score. They were either too fast or too slow with no middle ground. So, I built 3 drive modes into the code: turbo at full power for crossing the field, normal at 80% for general driving, and precision at 40% for careful alignment. The driver switches between them with the bumper buttons, so they always have the right level control for whatever they are doing. The next challenge was launching. Our operator had to manually spin up the motor, watch the RPM, and time the servo release for 3 times in a row under the match pressure. And on top of that, we found that battery voltage changed how fast the motor spun. So a launch that worked well on full battery would completely miss on a half-drained one. I solved both problems with a one-button launch system. The operator presses a single button, the code spins the motor to exactly 3000 RPM, so it's consistent, and then automatically fires 3 balls with a timed servo pulse. With just one button, the robot handles the rest. And the work doesn't stop off the field. Before every match, things can come loose and wires can disconnect. And if you don't catch that before you start, you've already lost points. So, I wrote a diagnostic test program that lets us check every motor and servo on the robot before a match to make sure nothing got unplugged or needs reconfiguring. That alone increased our reliability on the field. I also built a universal emergency stop into our competition code, because safety is always a priority on the field. If anything goes wrong during a match, one button kills every motor and servo on the robot instantly, and it's a safety net the whole team can trust. This season has been one of the best experiences I've had. I've sharpened my skills in Java, CAD, and real-time control systems, as well as learning how to design solutions around real people and real problems. And most importantly, I learned that the best engineering isn't about complexity, it's about reliability.